Hello, we're going to be recording here now. We have sequences here and there's a lot of sequence to go over. So what I'm going to do basically is cover some concepts here. As you can see right here, we have the 6 sequence to a 3. Now, when you have a sequence like that, it's an equals type of sequence. So if you have 6, now 3 plus 3 equals a 6. So we could assume there's going to be an equivalent sequence. So if it starts off with a 6 and then sequence to a 3, it could create another 3 sequence. It didn't, but it did it underneath. So that's something to remember when you're like these sequences go from left to right, and we got 6 sequences. This is roulette, by the way. It started off on 6 and it went to 3. So we're assuming another 3, but it didn't happen. So it landed on 26. And the reason for that is because it's also an equal statement, because the 26, for instance, right here I have the 6. And then it went to a 3-3 underneath here. See, so that's 6 and 6. 6 and 6 is equal to 12, as you can see right here. And that is equal to 26. And the reason why it's equal to 26 is because the 26 carries the statement 2 6s. What is 2 6s? 6, 6. And 6 plus 6 is equal to 12. So if this is 6 and 3 equals 6, that's 12. And one way to express it is by going into a 12 or going into the statement, which is 2 6s. 2 6s is 6, 6, and that is equal to 12. Another thing I wanted to explain is that it did, as you can see right here, you do have 26. It didn't diagonally downward to the, that's just a half step right there. Now, it could have sequenced to a 12, but it did a reverse sequence. Now that's when you have a hunch that it's going to sequence to a 12, that by a half step right here. What you want to do, you always want to play the 12 and the 21 as a reverse sequence. Now let's go on to another concept right here. I got the 24 is equal to 8, and it's equal to 0, 0. Now the reason why that is the case is that 2 4s, the 24 carries the statement 2 4s, and 2 4s is 4, 4. 4 plus 4 is equal to 8. So a 24 will sequence to an 8, or it will, 24 will sequence to a laying down 8. This is the laying down 8. It symbolizes 8. So as you can see right here, we do have the 0, 0, that's an 8. It's a symbolic 8. And it did sequence to a 24 right here. So 24, or 2 4s, which is 4, 4. 4 plus 4 is equal to 8. So this is a natural sequence right here. Now, one reason why it actually created a 24, 24 sequence here, like you can see that right there, is because this 14 it linked to this double 0 here, that expresses 48. The reason, now right here you have the 4 and there's the 0, 0, that's 48. This 1 is basically an I statement, I 48. So 24 plus 24 is equal to 48. So that's why that happened right there. Now, as you can see over here, you also have the double zeros right there, and underneath there you have the 14. So that, also expresses 48 as it does here. So what happens? This 24 sequence diagonally, a half step downward to a 24. So this 48 created a 24, 24 sequence. Plus 24 plus 24 is equal to 48. So that explains that. Now we're going to go into what is the 23 equals 33 equals 11, 11. Now, the concept behind that is that the 23 carries the statement 2 3s. What is 2 3s? 3 3s. So the 3 3 is also equal to 1 1 and another 1 1. Why is that? Because in binary notation, the 1, 1 is equal to 3. And this 1, 1 is also equal to 3. So what you have right here is 3, 3. So 2 3s, or 23, is equal to 3, 3, is equal to 11, 11. And as you can see right here, in this sequence here, you have the 11, 11. So the 2, 3, which is right here, sequence to this, created this sequence right here, the 11, 11, and it created the 33 here. So the 23 carries the statement 2 3s, which is 3, 3, and this is also 3, 3. So that explains, this is binary notation here. So let's go on to another concept here. I think I already explained this. Is the 3, 3 is also equal to an 8, and it's also equal to a downward 8, like this. So the reason why this is the case is because it's an anatomical sequence. You'll see a 33 sequence to an 8. And if you split an 8 in half, what you get is 3, 3. So that's why it's an anatomical sequence. Let's see if I have something like that. I guess I don't. No. So let's go on to another sequence here. What we have here is the 28 is equal to 2 and 0, 0. So this 2 right here, sequence to an 0, 0 here, that's number the 28. And the 28 is also equal to 16, because the 28 carries the statement 2 8s, which is 8, 8, and 8 plus 8 is equal to 16. Now, you will see in a lot of sequence that when you get a 28 like this, it'll sequence to a 16. But there are other ways of making 16. Now, for instance, right here, you have the 21, 22. Now, that is also equal to 16. Because if you were to add all the 2's, in other words, you got 2, 2, 2, that's 6. Linked to a 1, that's 16. So this 2, 8 sequence to this 16. I know that you're expecting to see 16, but it's not. It's 21, 22. That is equal to a 16. So this is it's a natural sequence. So the heads up would be, if you got a 28 here and you got a 21, you want to count on a 22 being here, because that'll form a 16. So let's go on to another concept here. We got the 2, 1 is equal to 11. So here you have the 1, 1 right here, right? So a natural sequence would be for that 11 to sequence to 21, as you can see right there. You got a 21. Over here you got the 11 again also, and that sequence to a 21. Why is the sequence to a 21? Because the 21 carries the statement 2 1s. What is 2 1s? 1, 1. So the 21 will sequence to 11, or an 11 will sequence to 21. All right, so let's go on to another concept. So I'm doing this. This is all related to this sequence right here. So we're going to go on to another concept here, and this is the let's see, the 21 is equal to 27. That's and the 24. Now, why is that the case? Because, okay, first of all, the 2111 sequence. This is right here, the 2111. Now, if you look at it, it looks like a 4. Like you see, it's like a 4 right there. So that's why symbolically it's 24. So this 1121 is equal to 24. And it's also equal to a 27, because you got the 111 here in binary notation. 111 is equal to 7 in binary notation. And when you link that to a 2, it makes a 27. So what you got is a 2 linked to a 111. That's 27. You can see right here, I'll bring this back up here. You have the 1121, right? And up above you have the 24. So this 24 is equal to this 1121. It's symbolically, because you have the 4 kind of shape right there. That's 24. Now, this also sequenced to a 27, because they're both equal to this. So again, the 24 is equal to 1121, and it's also equal to the 27. Alright, so let's go on to another concept here. We have the 5, okay, I think I already explained that one. Let's go on to this one. Yeah, I think I did explain that one. Yeah, this is the concept of right here, where the 16. And this is the way it looks. So you got a 3, 3, 3, that's 6, linked to a 1, that's 16. And that'll sequence to a 28. So there's your 28. I did that. Now let's go on to a 0, 0, 24, 60. Okay, so that would be this sequence, I believe, yeah. So what we have here, whenever you get 0 zeros like that, it adds up to something when it links to numbers. In this case, we got the 24. And what it adds up to is, on one side we got 40, and on this other side we got 20. So what is 40 plus 20? That's 60, right? And so what happens, it reproduces that theme. This is what you call a theme. Everything that has an equivalent sequence is a theme. So in this case, we do have a theme here, and the theme is 60. So over here we have the 22, as you could see, and this 22 creates another 60. And the way it does that is right. In other words, if we were to get the 2, 2, 2, 2 plus 2 plus 2 is 6, linked to a 0, that's 60. So this was equal to 60, and this was equal to 60. So if you capture that theme and you see a 22, then you could assume that it's going to go to a 20 to create another 60. So that explains that concept right there. That's these are all themes. Now, we got the 2836. Oh, let me find that one. Okay, so since this was a theme that's being played out, and so here's your 60, over here's your 60, and then it goes into diagonally on this step, about a half step away. It creates another 60, and the way it did it is by this 0 linking to this 6. This makes 60. So this themes could go on and on and on. In fact, over here you have a 6 right here, and that's sequenced to a 0 right here. And 6 tenths is 60. So this theme goes on and on and on. So it's good to know what themes are being played out, and that way you could use your intuition to make assumptions on. So this one's kind of easy, because if you have a theme of 60 and you got a 6 right there, well, you got to say, hey, if I throw a 10 there, it's just a half step away, it's going to create a 60, and you'd be right. So let's go on to another theme here. I think where are we at here? I think, okay, so this one is the 14 is equal to 0, 0. Oh, that's the 48. I think I already explained this, but I'll go over it one more time. This is the I-48, and that is equal to 48. And 48 is equal to a 24-24 sequence, and I already showed you that over here. How the, right here, you have the I-48, and it created this 24-24 sequence. So this is pretty easy, because if you got, knowing that this is 48 and it's sequenced to a 24, you got to go for another 24, because this is a strong sign that the 48 is going to be playing out a 24-24 sequence, and it did play it out over here, so it doesn't stop. Now notice how you did get the 0 zeros just like over here, and then you get the 14. So you gotta, and then it played out a 24 right here. So that really spells out that you're gonna be getting another 24. And knowing that the 24 and 14 already played out, it's gonna happen right here in a half step. And this happens to be the last place where it could sequence naturally. So you could make up for any, I mean, you want to put a lot of value in this sequence, because it's the last place where you could actually sequence. So in other words, 24 and 20 plus 24 is equal to this 48 here. So let's go on to another concept here. I think I already explained that right there. So we're on to this sequence here. And this is the 17 is equal to 4. Now, the reason why the 17 is equal to 4 is because it's an anatomical number. An anatomical number is that it means it's a number that symbolizes a 4. In other words, what we have, the 4 is an upside down 4. So it's the one number out of like in roulette, out of all the 36 numbers in roulette plus the zeros and 0. The 17 is the one number that looks like the 4. So we could call that an anatomical sequence when it does occur. And also, like the 17 linked to a 2 could also create 24. In other words, since this is a symbolic 4, right? Linked to a 2, it's like 24. That's equal to 24. It's also equal to 27 because by itself, like in other words, if this were 17 linked to a 2 here, this is just a I statement, I-27. So this is what they call a soft 27. So in this sequence right here, I think it's this one right here, you could see how the 2 linked to a 14, and over here it's sequenced to 24. Let's see, well that answers this sequence here, even though the reason why it did sequence to 24 was because of this 48. But this sequence here, the 24, is satisfied right here with this 24 being there. Alright, so now let's go on to another concept here. This concept, if I could find it here, I think it's this one here. This statement here says 2 27s. What is 2 27? It's 27 plus 27 equals 54. So in other words, when you have like a 22 linked to a 7, that's making a statement of two, virtually, in virtual memory, that there's 2 27s. That is 27, 27. So you could see that this here, you have it right here. So it actually creates 2 27s. And the way it does it is that by using its 7 here, it connects to a 20. Now, there's 2 ways you can make 27. You could do it with a 20, and you could do it with a 2. So you can put a 2 right here, and that'll link to a 7. That makes 27. But it used a 20 here, and so that's just half the story. You need to create another 27, because this is a statement that says 2 27s. And so you're wondering, well, where's the 54? The 54 is right here. The 54, this 5 linked to a 4, I mean, you could see it as 45, but it's actually 54 because of the 27 that's creating right here. So this is a hint of this sequence taking place. The 54, which is equal to 27 plus 27, there's your hint. And you already got a 7 there. So what you need is to complete this 7, or 27, you need a 2, either a 2 linked to a 7, or you need a 20. And so those are the 2 numbers you would have to play to create 27. Either a 2 or a 20. Linked to a 7, that makes 27. So that's only half the story. You got to create another 27 to equal 54, right? So so right here, a half step away, this is the last place where it could make a 27, and it actually did it. So you got to make up, this is a high value sequence right here, because this happens to be a half step away, and this is the only place where it could make that 27 sequence. So that's a nice thing to know. Let's go on to another concept here. Over here we have the 28 is equal to, 29 is equal to 18. Now, let's see. Okay, so the 29 is equal to 18. Now, as you can see over here, we don't have any 18s. It didn't happen. But we do have a statement here. This statement is used to link sequences. It's called the I-form statement. So this 20, every sequence here needs an answer. It needs an answer of an equivalent. It has to happen. That's the thing about, there's nothing random about sequence. We call it we called it random, but it's not. It's all relational. It's logical, and it has to be completed. So if you have a 29, the 29, the 29. Let me explain what the 29 is. The 29 is equal to 18. Why is that? Because the 29 carries the statement 2 nines. And what is 2 nines? 9, 9. And 9 plus 9 plus 9 is equal to 18. So if you have a 29, that's going to have to play out. And so what helps to bridge this gap here, which is the half step right here, is the I form statement. The I form, if I'm 29, I form 18. So diagonally. Now you want to follow the path. So if your 29 is here, and you're going diagonally right here, here's your statement, the I form statement. It's going to sequence right over here to the 18. So that's kind of nice right there. So take the path, it's already set, and then assume that it's going to go right in this spot right here. So this is a nice little sequence. And remember that every sequence here gets answered. It gets played out. There's no gaps. It's all in relationship. So let's go on to a... you already explained the I form statement. Now there is another number that also helps to link, and that's the 13. The 13 is the I am statement. So that kind of helps to bridge sequences. So even though it is, I would call this, like these are half steps, and this is more like a whole step. And that's about, the whole step is the last place where it could actually connect. It's the best sequences are the one that connects like a half step away, but it's not the end of the story. I mean, it got answered right there, and you want to follow the path. So if it goes diagonally like this, the answer is probably going to be over here, and that's going to be 29 is equal to 18. So that's a nice little sequence right there. So now we're going to go on to another one. This is the 611 sequence. Now, the thing about the 611 sequence, the 11, now there's one thing you have to know about the 11. The 11 in binary notation is equal to 3. So when you see an 11, it is equal to 3 also. So you got to take it in consideration. So over here, you have the 6 sequence right here. And I think this is it, is it? Yeah. Here's the 6 sequence right here, right? And the 6 sequence to a 3. Why did it do that? Because this 36 is a theme. Now, it's a theme to recreate itself. The way it recreates itself is by using this, because it's using this 6 right here, and it sequences to a 1, 1, which is in binary notation a 3. So what you have here is the theme, 36, and it's going to recreate itself by putting a 11 there, which is 3 in binary notation. 3 linked to a 6, that's 36. And it did it twice. As you can see, it put another 11 right there, right? So you got 36 and 36. What is 36 plus 36? 36 plus 36, I got it right here, is equal to 72. And that there in roulette, the highest number that you could actually have is a 36. So how it creates a 72 is by a reverse sequence. In other words, this 27 has two values. It has the number of 27, the way we see it, and it also has the value of the reverse number of it, and that would be 72. So the reverse of 27 is 72. So in virtual memory, this 36 and 36, which is equal to 72, it placed a 27 because the 27 in virtual memory creates a 72. So that's something you want to know. Especially if you got, like, say, 36 and 36, you know that it's going to play out a 72, a 27, because that adds up to 36 plus 36. So that kind of explains that. It's important to know that these numbers sometimes could be in virtual memory, the reverse of what you see here. So let's go on to another one. I think I already explained the I-48 24-24 sequence. Yeah, I did that. Okay, here is the 14 is equal to 2, 7. Okay, so what we have here is, here's your 14. Now, I told you that when whatever number you have here, it's going to be played out. I guarantee you, it's going to be played out. So if you say a 14 there, now you should know that the 14 is equal to 27. Now, the reason why that is because the 27 carries the statement 2 sevens. Now, what is 2 sevens? 7, 7. 7 plus 7 equals 14. So, if you have a 14 here, and over here, which is basically a whole step right here, it has to be played out. So if a 7, knowing that this is the last place where the 14 could connect, right here where the 7 is, you should be playing all 7s, because you're expecting this answer to be answered right here in this cell. This happens to be the last place where it could actually connect. And so in assuming that it's going to be a 7, you want to play 7, 17, 20, and 27. Those are all the numbers that have a 7. If one of those is going to connect, so that's why you want to play all 7s. 7, 17, and 27. You do that, you're going to connect on one of those. And once you've connected, because in this case it landed on 7, right? Now you know that the 20 is missing. Now, remember I told you that the 20 could be formed by putting a 2 right where the 20 is right here. A 2 connecting to a 7, that makes 27. And a 20 connecting to a 7 also makes 27. So this happens to be a half step away. So in this very spot where the 20 is, obviously you want to play a, two numbers for definitely. You want to play the 2 linking to a 7 or a 20 linking to a 7. But one thing that you want to look ahead into kind of like the future here, because let's say let's say that you're here in this spot where the 12 landed, right? And you want to know what the next sequence is right here. Well, one thing to know is that whenever you form a 35 like here, remember I told you that all sequences get answered? Well, here you got 35. Now, there's a statement right here that says 2. So this is 2 35s. What is 2 35? That 235 is 35 plus 35 is equals to 70. That's what, so you're going to have a number that's going to connect, a 7 number that connects to 0 to make a 70. So remember, this is 35, and it's linked to a 2, so that's a statement of making 2 times 35, which is 70, right? So what number can connect to a 0 to make 70? Well, it would have to be a 7, right? So knowing that this sequence here has not been satisfied, right? And so these sequences have all taken place, boom, boom, and all of a sudden you land on a 7. So this is a heads up that this 7 is going to link to a 0 to make 70. So right here, this 7 links to this 0 to make 70. So if you're in this location, you're going to say, I got a 7 right there. That might link to a 0. So this number is probably going to be a 35, because you're going to probably sequence to a 35 and a 35 right there. It's a 35 and 35. So you could assume a 35 being right here, and then assume that this is going to be a 27 connection with the 0 right here, because this 7 has to connect to a 0 to make 35 plus 35 equals 70. So here's your statement. 2 35s, that's 70, right? And you happen to be right here, and you got a 7. So this 7 right here has to connect to a 0. So it's going to do it right there, and it's going to create a statement of 35, and then it's going to roll over here, and this is going to sequence to a 3 right here, like 23 right here. And as you can see, it didn't link to a 5, so that's quite all right. It did link to a 7, because this 7 now sequences to a 0 here, but this is 27, 27, that's equal to 54, I think it is right here, 54. So this was a heads up to this 27, 27 sequence. But as you can see right here, you do have a 35, and right here you have a 35. So that kind of explains this sequence. Remember, every sequence gets answered. You got to figure out how it's going to answer it. So the fact that the 7, you saw the 7 there, that was heads up that this 7 was going to link to a 0 of some sort. Now, if you wanted to, if you didn't know, you could play all zeros. Like in this sequence right here, you could play all zeros, and you would hit on obviously on 20, because if you played all zeros, it would be 0, double 0, 10, 20, and 30. One of those is going to hit. One of them has to hit. In this case, it hit on 27. So in a situation where you know there's going to be a 0, obviously you want to play all zeros, and that would be 0, double 0, 10, 20, and 30. And one of those is going to hit, especially when you got a 235 statement, and this is the 7 right there, so you know that 7 is going to be linking to a 0. So that's a concept right there. Another thing is that as you could see that all these zeros were being formed right here. You got a 7 0 right there, and you got a 7 0 here, and it doesn't stop. It keeps on going, and you could do that with the 11. In other words, this 11, if it's sequenced to a 10, it will make a 70 also. And let me show you how that has done. Because over here, the 11, 10, if you were to add, like say, these are binary digits here. So if you put 111 in binary notation is equal to 7. Linked to a 0, you got 7 0. So that's why the 11, 10 sequence, that's equal to 70. Because that's 111, that's 70 in binary notation. That's 7 in binary notation. Linked to a 0, that's 70. So these themes just go on and on and on. So you can see how the 7-0 sequence was a important sequence. And so now we're going to go into the very last concept here. And I got I think the 26 is equal to 12. And it's also equal to 21 as a reverse sequence. So the reason why the 26 is equal to 12 is because the 26 carries the statement 2 6s. What is 2 6s? 6 6. And 6 plus 6 is equal to 12. So in this situation right here, like you could see how the 26 is right here, and you say, it's going to sequence right here to a 12. Now this happens to be the last place where this you can make this sequence here. It's a half step away. So if you're going to be playing a 12, you got to be playing a 21 because it could play itself as a reverse sequence. So remember, if you have 26 and you're going to play out a 12, play a 21 too, because you never do know if it's going to play out as a reverse sequence. So in this case right here in this cell, I would play 21 and 12, obviously. Now, the nice thing about it is that this happens to be the very last place where you could actually make that connection. So that's a high value sequence right there. So that's pretty much it. I hope you enjoyed this lesson here, and we'll catch you later on the next random sequencing.